Hi guys, today what I'm going through is exercise 907, questions 4 to 9. So for question 4, what we're doing is matching graphs A to G with the equations below. Now what this exercise is all about is the gradient intercept form of a straight line, which is y equals mx plus b. This is where m equals our gradient, and to calculate our gradient we use the formula m equals rise over run, and then our b equals our y-intercept. So what I'm going to do is I'm going to look at my graphs. I'm just going to do A and B, and then you can do C to G, and I'm going to match them. So for A, we have the equation y equals x. Now, what I'm going to do is I'm going to find my gradient, and I'm going to find my y-intercept of this graph. So my gradient is the coefficient of x. My coefficient of x is 1. There's nothing there, so it means that it's 1, and my y-intercept, there's nothing added or subtracted on, so my y-intercept is 0. So now I want to look at my graph, and to have a y-intercept of 0, it is at this point here, and then my gradient of 1 is rise over run, so it's 1 over 1, so I will rise 1, run 1, rise 1, run 1, rise 1, run 1. So that means that my graph of y equals x is this graph here, which equals E. So that means A equals E. Then for B, what I want to do is I want to write out what my gradient is and what my y-intercept is. So my gradient is my coefficient of x. Now my coefficient of x in this equation is -2. What that means is I will have a rise over run of -2 over 1. So back up here we had a rise over run of 1 over 1. My b is my constant. Now my constant term is 6. So my b is 6. So now what I'm going to do on my graph, I am looking for where my y-intercept of 6 is, which is here. And then what I'm going to do is I'm going to rise -2, so that means fall -2, and then run 1. Fall, fall. And that is leading me onto this purple graph of B. So that means that equation B matches up with line B. So now you can have a go at doing C to G. For question 5, what you guys are doing is A, B, and C. So what I'm going to do is I'm going to do equation D on another page. So what we're doing is by first changing the equation into the form y equals mx plus b, we want to find the gradient and the y-intercept of the following. So I want a new page. Now this is exercise 907, question 5, and I'm doing D because you have to do A, B, C. So for D, we have the equation 3y equals 6x minus 3. And what we're trying to get it into the form of y equals mx plus b. So what we want is we want that y to be by itself. So what we have now is 3 times y. So I'm going to divide both sides of my equation by 3. So what that means is I'll have y equals 6x over 3 minus 3 over 3. So we have to divide both terms of 6x and minus 3 by 3. So what we get here is y equals 6x divided by 3 is 2x, minus 3 divided by 3 is 1. So now we have this in the form of y equals mx plus b. So our m, which is our gradient, is our coefficient of x, which is 2, and our b, which is our y-intercept, is our constant of minus 1. So you were to have a go at A, B, and C there. What we have for question 6 is you're not doing question 6, so we're not going to go through it. Now, for question 7, we want to know which of the following lines are parallel to y equals 2x plus 3. So if two lines are parallel, they have the same gradient, like it says here. So our gradient in this equation of y equals 2x plus 3 is a gradient of 2. So what you want to do is you want to find the equation with a gradient of 2. Now, I'm not going to do that for you. I think you should be able to do it yourself. There is only one equation there that has a gradient of 2. And you might have to move some things around. Oh, actually, there's 2. I lied. There is 2 equations that have a gradient of 2. So you can pick which ones it is. Then, which of the following lines are parallel? So for this one, we want the 2 gradients to be the same. So what you want to do is you want to rearrange each of the equations to be in the form of y equals mx plus b. So this first one's already in the form of y equals mx plus b, but this second one isn't. So we'd have to minus the x from both sides to get y equals 3 minus x. This one's in the form of y equals mx plus b. This one is not, and this one is. So we'd have to rearrange this one. We'll have to divide by 3 to get y equals x over 3. Now that they're all in the same form of y equals mx plus b, you need to work out what their gradients are and which ones have the same gradient. For question 8, we're going to draw the graph of each line on a separate number plane by following these steps. So first what we're going to do is we're going to mark the x-intercept, then we're going to count the gradient, and then we're going to draw a line through the second point and the y-intercept. So I will, you're doing so the questions that you are doing is A, C, E, and G. So what I will do is I will do question B. So on a new page, so this is exercise 907, question 8b. We have the equation y equals x plus 2, y equals x plus 2. Now first I want to look at how it's in the form of y equals mx plus b, and I'm going to identify my gradient and my y-intercept. So my gradient here is 1, my y-intercept is 2. What I'm then going to do is I'm going to draw a set of axes like so, and put our values on there. Just going to go from 1 to 4 in each direction, including a -4. Okay, so then this is my y-axis, this is my x-axis, like so. So I've been told that my y-intercept is my b value here of 2. I then want to work out my gradient. So remember, my gradient is rise and run. So that gives me this point here. Oops, this point here. Then we have another rise and run to get our next point. And then we have our rise and run to get our next point here. We can also go back the other way, so we can fall and run to get our point 1, but we're going the other way, and fall and run to get our point here. What I then am going to do is I'm going to draw a straight line through my points, super straight, and then I'm going to add arrows on the end, and I'm going to label my equation y equals x plus 2, like so. And finally, question 9 is an extension or a challenge question, and we want to graph the lines with a y-intercept of 1 and a gradient of 0, 1, 2, and -1 on the number plane. So what we would be doing is we're graphing the lines y equals, we have gradient of 0 and a y-intercept of 1. Remember, using the form of y equals mx plus b. So we have a gradient of 0. So this will be 0x plus 1 here. Then we'd have a gradient of 1 and a y-intercept of 1. So this will be y equals 1x plus 1. A gradient of 2, a y-intercept of 1. So y equals 2x plus 1. And finally, a gradient of -1 and a y-intercept of 1 to get y equals -1x plus 1. You then want to graph those lines on the same number plane.